Hi everyone, welcome to the Mathemagic channel. Today we will look at a formula from a very famous Indian mathematician who goes by the name of Brahmagupta. Now before we start, please press that subscribe button so that you can see more videos and watch all of our exclusive content. Thank you. Now, what is this formula that we talk about? Well, Brahmagupta's formula is a formula that's quite specific, and you might be able to use it when you're faced with a cyclic quadrilateral. A cyclic quadrilateral, simply put, is a quadrilateral that is inscribed inside of a circle. Each one of the points on the quadrilateral must be touching the circle for it to be considered inscribed in the circle, like in the example on the screen. We see here that A, B, C, and D are all touching the edges of the circle. Therefore, this is what we call a cyclic quadrilateral. Now, you may know that the opposite angles in a cyclic quadrilateral add up to 180. So A and C add up to 180. They're supplementary. And B and D also add up to 180. They're also supplementary. But there's more. We also have Brahmagupta's formula. And so using his formula, we can find the area of a cyclic quadrilateral. Mr. Brahmagupta lived from 598 to 668 CE, which is the Common Era. He was an Indian mathematician and astronomer. He gave us the first rules to count with zero. Some people say he's credited with creating zero, but that's up for debate. He wrote mostly in Sanskrit, which is an ancient Indian language. There are no proofs in his work, so most of his work are just results. So we don't know how he proved the results that he proved or how he found the results that he found. But for the most part, he came up with some very interesting results without any proofs. A lot of the materials he published were written in elliptic verses, which might mean that they were a little bit poetic. It's not very clear. Anyway, they were not just literal texts, so a lot of it might be open to interpretation. However, he did find solutions to linear, quadratic, Diophantine, and simultaneous equations, as well as Pythagoras' theorem and some other very famous results. So he's credited with some awesome mathematics considering the tools of his time. He also described gravity way before Newton did, but not without having quite formalized what it is. He was clear on the idea that objects went down towards the earth, however. So Brahmagupta's formula, what is it? Well, here's the formula. We take a quadrilateral that's inscribed inside of a circle and we find the semi-perimeter. So we add up all the lengths and we divide by 2. And then we subtract the semi-perimeter, we subtract each length from the semi-perimeter. So we'll do the semi-perimeter minus each length, S minus A, S minus B, S minus C, S minus D. And then we will square root that result and we will find the area of the quadrilateral. Now, I know what you're thinking. If some of you are doing a lot of Math Olympiad work and you've seen a formula like this with semi-perimeters before, it looks a lot like Heron's formula. Yes, we calculate the semi-perimeter, we take the square root, we subtract the sides. These are quite similar. In actual fact, you could derive Heron's formula from Brahmagupta's formula, and you could also derive Brahmagupta's formula from Heron's formula. So both of them are very, very close. It's easy to prove one using the other. Now let's look at an example here. Let's imagine for a second that we have a quadrilateral with measurements 5, 7, 4, and 6. What's the first thing we do? Well, we find the semi-perimeter. And the semi-perimeter will be done by finding the perimeter, so 4 plus 5 plus 7 plus 6, and dividing that by 2. So as we find the semi-perimeter, 7 plus 5 is 12, 12 plus 4 is 16, 16 plus 6 is 22, 22 divided by 2 is going to be 11. So half of the perimeter is 11. And so now to actually use the formula, what you need to do is you need to do 11 minus each side. So you'll do 11 minus 7, 11 minus 5, 11 minus 4, and 11 minus 6. So each side is going to be let's say 11 minus 5 is 6, 11 minus 6 is 5, 11 minus 4 is 7, 11 minus 7 is 4. So we're going to end up with an area which is 840, but we need to square root it. So it's going to be the square root of 840. Now 841 is a perfect square, which is 29. So the square root of 840 is just about under 29. Now, since we haven't assigned any units to this, we can just say unit squared. If this was in meters, it would be meter squared. Cm will be cm squared, and so on. So what a beautiful formula to find the area of a quadrilateral if it's inscribed inside of a circle. And if you'd never seen this before and you saw it in a Math Olympiad question, you might not know how to do it. But now that you've seen this video, I hope you remember to use Brahmagupta's formula whenever you see it. So thank you for watching this video. Remember to follow our channel. We appreciate your support. This was Brahmagupta's formula, a wonderful formula that you need to know for Math Olympiads. For more videos, go and click on some of the other ones. Give us some views, and if you have any comments or suggestions, we'd be happy to see them. Thank you.